Hi guys, now we are going to discuss about the topic Chemical Kinetics CBSE grade 12. As we know, kinetics means movement. So here we are going to discuss about the rate of a chemical reaction or speed of a chemical reaction. What's the importance of speed of chemical reaction or rate of chemical reaction? Some reactions occur in a faster speed, but we don't need that much speeder or faster. So what we will do? We will try to reduce the speed of reaction. Example, in the case of foodstuffs that we are buying in bottles and packets, if we are keeping that foodstuffs in outside, what will happen? It will undergo oxidation, that means rancid reaction. It will undergo decaying, simply decaying. We don't want to decay it fastly. So what we will do? We will add some kind of sodium benzoate. The companies will add some kind of sodium benzoate. So the rate of decaying will be decreases. Likewise, some reactions we have to make it faster, some reaction we have to make it slower, some reaction we have to make it in an average speed, in a moderate speed. To learn about that, according to our wish, we have to convert the speed now, we have to control the speed of reaction now. For that only, we are going to learn about the rate of reaction, that means the chemical kinetics. In the case of thermodynamics, once we go to the thermodynamics, I think you learned about thermodynamics, right? In thermodynamics, you learned like that the speed of, you are learning only about whether the reaction will occur or not. According to thermodynamics, you may be learned like that what? Diamond can be converted to graphite very easily. That means its delta G is negative. Delta G negative means that reaction is spontaneous. Sir, if you are keeping diamond, will it convert it into graphite? In our pencil lead and all, that all are graphite. Easily, sir. Yeah, delta G is negative. But unfortunately, the speed of reaction is very slow. It will take years. So automatically crores of years it will take. So automatically, if we are trying to conduct this reaction, it won't occur. We cannot tell like that it won't occur, but the speed of reaction is very less. So there is an importance of chemical kinetics. If we know whether the reaction occur or not is not enough, along with that we must have to know in which speed, in what speed that reaction will occur. I hope you understand. So to learn that rate of reaction and how the reaction occurs, that means reaction mechanism as well as factors affecting rate of reaction. All these three are governing by using what? Chemical kinetics. So what are the ideas we are going to learn? We are going to learn mainly about what? Rate of reaction as well as what? Reaction mechanism. So this is the first thing we are going to learn, rate of reaction, and second thing, reaction mechanism as well as what? Factors affecting rate of reaction. Factors affecting rate of reaction. These 3 points are mainly included in chemical kinetics. So first of all, we can discuss about what? Rate of reaction. What is rate of reaction? As we know, the idea, a reaction means reactants react to give what? Reactants react to give products. Reactants react to give what? Products. So in the case of reactants, whenever the time is going, that time the concentration of reactants will decreases. Continuously it will decreases. At the same time, the concentration of product will increases. So how we will tell about rate of reaction? So rate means we know that we learned it is like that. Rate means something divided by time. Correct? Like gradient means something divided by length. Likewise, we are telling rate means what? Something divided by time. What divided by time? Here we can tell the rate of reaction in terms of reactant or in terms of what? Products. In terms of reactant's concentration is decreasing. So how we can tell the rate of reaction in terms of reactant? So this is equal to the decrease in concentration of reactants by time. or in terms of products, how we can tell? It is the increase in concentration of products divided by time. Increase in concentration of products by what? Time. So we can tell the rate either in terms of reactant or in terms of what? Products. Like what? In terms of reactant, it means decrease in concentration of reactant by time. In case of products, how we can tell? Increase in concentration of product divided by time. Correct, right? So this rate of reaction we can represent mainly in two ways. That's actually we are going to learn about what? The two types of rate of reaction. So suppose if we are measuring the rate of reaction within a small time interval, then that rate of reaction is called instantaneous rate of reaction. What? Instantaneous rate of reaction. That is called instantaneous rate of reaction. Okay, instantaneous rate. That we are representing like R insta. Okay, R insta. Likewise only we will represent. And the second one, if we are measuring the rate of reaction in a large interval of time period, then that is called what? Average rate of reaction. What? Average rate of reaction. Average rate of reaction. Okay, average rate, that we will represent RAVG, R average. So that this kind of idea you already learned in physics, I hope. Like what? Average speed, instantaneous speed, like that. Correct now? So here we are going to discuss about what? Instantaneous rate as well as average rate. So we can look about what is instantaneous rate, what is average rate. Okay, how we can find this R instantaneous as well as R average. You know what it is. We know that instantaneous rate means the rate of reaction measured at a particular instant. So at this time, at 2 o'clock, or at a 10th second, what will be the rate? Likewise, if you are measuring means that is instantaneous rate. And if you are telling in 2 to 3 o'clock, 2 o'clock to 3 o'clock, what will be the rate? Or else in between 90 minute to 110 minute, what will be the rate of reaction? Likewise, in large time interval, if you are expressing the rate means that is average rate. That idea you know. So in graphically, how we can find this one? That's the idea. Listen to me very carefully, guys. Okay, I'm going to draw the graph. You can see. Listen to me very carefully. So once we are looking, okay, listen to me. Once we are looking this one, the graph, I'm going to draw a graph between, this is the graph between concentration of reactant versus time graph I am going to draw. This is concentration of reactant. Okay, here in y-axis I am taking what? Concentration of reactant, and in x-axis reactants, and in x-axis I am taking time. Okay, time in second. Okay, no issue. This is concentration of reactant I am taking. Then tell me at a time t equal to 0, I mean I am going to start the reaction. What will be the concentration of reactant? What will be the concentration of reactant? At a time t equal to 0, we must have a lot of reactants will be there. Maximum reactants will be there. That we will represent it as maximum reactant means that we will represent it as concentration of R0. How we will represent? Concentration of R0. That represent the initial concentration of reactant. What it represent? Initial concentration of reactant. Whenever the time is going on, the concentration of reactant will decreases. The concentration of reactant will decreases. At the same time, the concentration of product will increases. Correct now? So here, what will happen? The concentration of reactant will decreases. So whenever the time is going on, the concentration of reactant will decreases like this. Okay, it will decreases. Correct? So what I am going to do? I am going to find out the instantaneous rate as well as average rate for this reaction. How I can find out? So I am taking, you can see, I am taking here you can see at a time t1, at a time t1, this is the time t1, at a time t1, the concentration of reactant I am taking it is R1. What? R1. Okay, similarly, at a time t2, I am taking concentration of reactant is what? R2. Concentration of reactant is what? R2. Then now we have to find out what? In between the time in between the time interval T1 to T2, what will be the rate? That rate is actually T1 to T2, large time interval is there. So in that time period, if we are trying to represent the rate of reaction, that rate is called R average. That rate is called what? R average. So how I can find out R average? I already told you rate of reaction is what? Concentration, decrease in concentration of reactant by time. So here, how we can find out the decrease in concentration of reactant? Final concentration of reactant minus initial concentration of reactant. What's the final concentration of reactant? R2. So I can write concentration of R2 minus initial concentration of reactant R1 divided by time. Time is T2 minus T1. T2 minus what? T1. But there is a problem. While you are calculating this value will be negative. Why it will be negative? Because R2 is smaller, R1 is bigger, because at the initial time that reactant concentration is maximum. Then at T1 time the concentration R1 will be maximum. So that's why R2 is a smaller quantity, R1 is a bigger quantity. So the answer will be negative. So what the scientists did was, actually they put one negative in front of that one. They put one negative in front of that one. That is for sign convention. And they are telling like that this negative represent what? Decrease in concentration for reactants. What? Decrease in concentration for reactant. So this one we can write like that, negative R2 minus R1. I am writing delta concentration of R divided by delta T, divided by delta T. Likewise, we can represent R average. I hope you got the idea very clearly. Similarly, if I want to calculate the instantaneous rate at a time period T3, I am considering some time T3 here. Okay, some time T3 here. Here I am considering some time T3. Then how I will find out at a time T3, what will be the instantaneous rate? So how I can find out? I can draw a tangent here like this, a small tangent here, and I can make a small triangle here. Okay, small triangle. In the x-axis, the change is dt. dt means small change in time. Small change in time. And here in y-axis, the change is dr. dr means small change in concentration of reactant. dr means small change. Delta means big change. Okay. So R insta, how I can write? R insta equal to small change in reactant. That is dr by dt. dt. But here you know that this tangent, this slope actually is a decreasing slope. So that value will be negative. To avoid that one, what scientists did? So they put one negative in front of that. So that negative represent what? Decrease in concentration. So if you are representing the rate of reaction by using reactants, we have to put some negative there. That negative represent what? Decrease in concentration. Don't forget it. Okay, idea clear, right? So then same way we can express the R average as well as R insta in terms of product also. How, sir? Same way we can draw the graph for product. How it will be? Listen to me very carefully, guys. Listen to me very carefully. Okay, it's going. Okay, so let's see. I'm going to draw the graph between what? Product versus time. Product versus what I am going to draw? Product versus time. So here I am taking concentration of product. Okay, concentration of product, as well as here I am taking what? Time. Here I am taking time. And tell me, at a time t equal to 0, what will be the concentration of product? Is it maximum? No. No. At a time t equal to 0, reaction not started till yet. That time, the product concentration is 0. 0. What? 0 only. At that time, the product concentration is 0 only. Here only. And whenever the time goes, what will happen? The reactant concentration decreases. Product concentration increases. So the graph will be, whenever time goes, the product concentration increases. The graph will be like that. Okay. Oh, this is unknowingly come, guys. I'm sorry. Okay. So like this only the graph. Okay. So By using this graph, how we can represent, how we can express the R average as well as what? R instantaneous. Let's look about R average first, okay? I hope you guys are enjoying, correct now? So here, I'm taking, this one is T1. At time T1, what will be the concentration of product? Here, I can draw here. So that is, I am taking P1, and at time T2, what will be the concentration of product? This is P2, okay, this is P2. Then how I can express the R average? R average I can express in terms of what? R average I can express in terms of product, like what? It is the increase in concentration of product. So final concentration of product is P2 minus P1 divided by T2 minus T1. But there, in the case of reactants, what we did? We put one negative there. But this is actually positive only. No problem. P2 is maximum and P1 is minimum only. I mean, this is larger, this is smaller only. So this is value is positive. Even though we will put what? One positive here. Why? That positive represent increase in concentration. Like in the case of reactant, we put one negative that represent decrease in concentration. Okay. So here that we can represent plus. P2 minus P1 we can represent as delta concentration of P divided by what? Delta T. So likewise we can represent. Correct? Similarly, how we can represent R insta? Suppose I am taking T3 here. This is the T3. At T3, what will be the rate of reaction? What I have to do? I have to draw a tangent here, and I have to make a triangle like this, okay? And the x-axis, small change in time, that is dt, and in y-axis, small change in product concentration, that I have to take dp. So this one, how I can write R insta? R insta equal to what? Plus dp by dt. Why I am putting that plus there? Plus means this is the increase in slope, as well as that plus means what? The increase in concentration of product. So generally, in the case of generally, once we are representing a R gives P, a reactant to give product. Suppose this is the reaction. We can represent R average in terms of reactant, like how we can represent the R average by using reactant? Simply, I already told you, minus delta concentration of R divided by what? Delta T. And that will be equal to, how I can represent in terms of product? That will be plus delta concentration of P divided by delta T. Correct, right? So likewise I can represent in the case of R average. But if it is R instantaneous, how we will represent? R instantaneous means that is in small time interval, that we will represent as minus d by dt of concentration of R. That will be equal to plus d by dt of concentration of what? P. Likewise we can represent. But unfortunately, in our case, reactant gives product. Our reactions may or may not be like this. What, sir? What may not be, sir? Let's look. So that's why only I wrote instantaneous and average rate of general reaction. Our general reaction is not like this. Then like what? Like this only. I will write go. Okay. So like this only. Like what only? Like this. AA plus BB gives CC plus DD. Like this only. Our reaction may be like this, generally like this only. You may be see N2 plus 3H2 gives 2NH3. The stoichiometric coefficient also may be there. That time, how we will represent the rate of reaction? That's the thing. That's the general idea you have to remember. From this much ideas, you have to remember this idea only, mainly. So how I can write R average? I can tell R average either in terms of A, how much amount of A decreases in a particular interval of time period, or else how much amount of B will decreases. Both will be both should be equal. In the case of rate, both should be equal. And how much amount of C increases? How much amount of D increases? So you have to remember, if it is a reactant, if I am going to represent the R average in terms of a reactant, we have to put what? One negative there. That negative represent what? Decrease in concentration. And the stoichiometric coefficient, I have to keep it as what? Reciprocal. So minus 1 by A. And then I have to write delta concentration of A divided by delta T. This is the rate of reaction, average rate of reaction in terms of A. Similarly, in terms of B, how I can write? Minus 1 by B delta concentration of B divided by delta T. Delta concentration of B divided by what? Delta T. This B will come as, this stoichiometric coefficient will come as what? This reciprocal. And in terms of C, how I can write? In terms of C, C means is the product. So I have to put plus here. So plus, its stoichiometric coefficient small c. Small c should come as reciprocal 1 by C delta concentration of C divided by what? Delta T. That will be equal to, in terms of D, how I can write? Plus 1 by D delta concentration of D divided by what? Delta T. So I can represent the R average in terms of A, in terms of B, in terms of C, in terms of D also. Similarly, how I can represent R instantaneous? Look at here carefully. R instantaneous, how I can represent R instantaneous? I can represent like this. Listen to me very carefully. This is our general reaction. R instantaneous is equal to, R instantaneous is equal to, I can represent in terms of A. Instead of this delta, I have to put what? D by dt, small change. So negative 1 by A d by dt of concentration of A, that will be equal to negative 1 by B d by dt of concentration of B, that will be equal to plus 1 by C d by dt of concentration of C, that will be equal to plus 1 by D d by dt of concentration of D. So this is the idea you have to remember, guys. Okay, this is the idea you have to remember. Likewise only, we are representing what? R average as well as R instantaneous of a rate of reaction. I hope idea is very clear. Okay, we will see with another video. Up to that, thank you.